Throughout history, people have often assumed that reality is fixed and objective, something we can all agree upon. Yet unsettling questions persist about whether our world is truly as solid as it seems. What if the reality we experience is shaped by forces beyond our understanding, or perhaps even constructed by something else entirely? These mysteries challenge our perceptions and invite us to reconsider what we know about existence. As we explore these ideas, the very foundation of what we call reality comes into question. The Matrix captivated audiences with its groundbreaking visuals and storytelling, but for physicists, it resonated on a deeper level. The film's central premise, questioning whether reality is merely a sophisticated simulation, mirrors ongoing scientific debates about the nature of existence. It also explores the role of consciousness in shaping our perception of what is real, a topic that has intrigued philosophers and scientists alike. By weaving these profound questions into its narrative, The Matrix became more than just entertainment. It offered a thought-provoking lens through which to examine the boundaries between illusion and reality. Quantum physics reveals a world that challenges our everyday understanding of reality. At the smallest scales, particles do not have definite positions or states until they are measured. Instead, they exist in a haze of probabilities, where multiple outcomes are possible at once. This means that reality itself seems to be shaped by the act of observation, as particles only decide their state when someone looks. Such behavior defies common sense and continues to intrigue scientists and philosophers alike. Some theories propose that reality might not be continuous, but instead rendered on demand, much like a computer generates graphics only when needed. In this view, space and time could be fundamentally pixelated, composed of discrete units rather than smooth expanses. Information would be conserved and processed similarly to how data is managed in computational systems. This perspective suggests that the universe could operate according to underlying rules, resembling the logic and structure of computer code. Such ideas challenge traditional notions of reality, inviting us to reconsider the very fabric of existence. Some researchers have proposed that consciousness may not simply be a byproduct of the brain, but rather a fundamental aspect of reality itself. This idea suggests that consciousness could act as a kind of glitch in the system, influencing the very fabric of existence. According to certain interpretations of quantum mechanics, it is the act of observation, potentially linked to conscious awareness, that collapses a range of quantum possibilities into a single tangible outcome. If consciousness truly plays this pivotal role, it may be responsible for shaping reality in ways we are only beginning to understand. Such theories challenge conventional views and invite us to reconsider the nature of both mind and matter. The simulation hypothesis suggests a thought-provoking possibility. If simulated universes greatly outnumber real ones, then statistically, it is more likely that our reality is itself a simulation. This idea challenges our understanding of existence, proposing that what we perceive as the physical world may be the product of advanced computational processes. Supporters of the hypothesis point to the apparent fine-tuning of physical constants, which seem precisely calibrated to allow for life and complexity. Such precision, they argue, could be evidence of deliberate design within a simulated environment. The concept invites us to reconsider the nature of reality and our place within it. Considering the possibility of a matrix-like reality challenges our understanding of what is truly real. If the boundaries we perceive are shaped more by our minds than by physical constraints, it raises profound questions about the nature of existence. By exploring and comprehending the underlying system that governs our experiences, we may discover new pathways to freedom. This perspective suggests that liberation is not just about escaping physical limitations, but about expanding our awareness and perception. Ultimately, understanding the system could empower us to redefine what is possible within our reality. As we reach the end of our journey, it's clear that the mysteries of quantum reality and consciousness remain vast and intriguing. The more we uncover, the more we realize that reality may be far stranger than it first appears. If these questions have sparked your curiosity, Consider exploring further into the fascinating realms of physics and the mind. Who knows what new discoveries await just beyond the boundaries of our current understanding? The adventure into the unknown is only beginning.